Hello guys, you're welcome to my channel, and in this video I'll be telling you about solar installation, the cells, the battery, and how long a given installation will deliver power to our load. So all you have to do, if you have not subscribed to my channel, you just have to hit the subscribe button and subscribe so that you'll be getting more interesting videos, because I have lots of them on technology. I have the one on inverter, they have to design an inverter, and a lot of them. Just stay tuned to my channel. So this is a solar panel which can be rated in 200 watts, 150 watts, 250 watts, 350 watts, 450 watts, as the case may be. And this is also a battery that we normally use. We have different types. You can see this is rated 200 ampere hour by 12 volts. It means it can deliver 200 amps for 1 hour. Wow, that's a whole lot. So, and this is nice for you to have a load of 200 amps. You can know how big and large your load will be. Alright, so I said the cell is 250 watts. The one we are using is 250 watts by 12 volts, and it delivers 10 amps. The battery we are using is 12 volts by 200 ampere hour. Then the total load for this design, for this video, is 2000 watts. And the inverter rating we are using is 3000 watts. It's always advisable to go for an inverter rating that is a little bit above your demand. You know, our demand here is 2000 watts, so it will be unreasonable to go for 2000 watt inverter. That will weigh the inverter down. So always go for, you know, the next higher in size for inverter. Now the question for this tutorial says, how many hours will 4 panels, because we are using 4 panels for this, and 4 batteries, how many hours will 4 panels charge the battery, and how long will the battery deliver 2000 watts at 200 volts of load at full charge, assuming the voltage coming out from the inverter is 200 volts. You know, usually the demand for residential building is 230, 220, 240, 180, 190. All this can serve, but there are some loads that require specific 220, 230. But in this video, I'm just assuming that our inverter is giving at 200 volts. So, and we are using 4 panels and 4 batteries. That's what we are using for this explanation. So just take note of this question. How many hours? We are looking for how many hours it will take us to fully charge the batteries we are using, and how long at full charge will it deliver constant supply to our load. You get the answer. Next. Then we have inverters that are rated in 24 volts input, 12 volts input, 48 volts input. If an inverter is rated in 24 volts input, all you have to do is arrange your battery or your solar so as to meet the input demand of the inverter. Like in this case, if it is 24 volts, the batteries and or the cells has to be arranged in such a way that it will supply 24 volts to our inverter. How do you get 24 volts? You know, batteries, when they are in series, the voltage tend to increase, and when they are in parallel, the current tends to increase. A battery is rated 12 volts, so you want to increase the voltage, we add another one in series, making it what, 24 volts. In this case, this is 12 volts. We don't need to add anyone in series. No increase in voltage is required here. All you have to do, the remaining batteries, connect them in parallel. Now this is 48 volts. In this case, you have to arrange 4 batteries in series to be able to get the 48 volts. So the same thing is applicable to the solar cells. You arrange it in order to match the specific inputs of the inverter you are using. Now I said we are using 4 cells and 4 batteries. So you can see, remember our inverter is rated 24 volts. That's why we have arranged these 2 in parallel in series to give us 24 volts. Because we are using 4 cells, you now arrange the remaining one in parallel. No need to increase it. So when they are in series, current stays the same, voltage increases. When they are in parallel, voltage stay the same, current increase. So in this case, current is staying the same and voltage has increased to 24 volts. Right here, the same thing happens here, but because this is in parallel with this, the current will increase because this is 10 amps and here is 10 amps, making it what, 20 amps. That's how we got this. So the output from our solar installation is 24 volts, 20 amps. This ought to be going to our inverter and to our battery. For the battery, the same thing. We say the battery is rated 200 ampere hour by 12 volts. So this is, when these are in series, it gives us 24 volts, and when they are in parallel, it will double this, making it what, 400 ampere hour. So we are charging this 400 ampere hour with this solar installation, which is 24 volts, 20 amps. All right. Okay, so remember, we now have 400 ampere hour as our energy, and this is what we are going to charge. It will take us, if the supply from the solar is 400 amps, it will take us 1 hour to charge the battery. If the supply from the solar is 200 amps, it will take us 2 hours to charge the battery. And if it is 100 amps, it will take us 4 hours to charge the battery. You see, I'm getting the formula. You see, 400 divided by the 20, that will give you 20 hours. In case of here, 400 divided by 100, that will give you 4 hours. So if the supply from our solar, which is what is our design is 20 amps, it will take us 20 hours to fully charge the battery. And if the supply from our solar is 40 amps, it will take us 10 hours to fully charge the battery. Like I said, this is the formula. The total battery capacity divided by the current that is charging it, that will give you the duration or the time it will take to charge the battery. And if the current is 80 amps, it will take 5 hours to charge the battery. So for this case, our current is 20 amps, so it's going to take us 20 hours to fully charge the battery. So I think that answers one of our questions, that how long will 4 panels charge the battery. So it will take 20 hours to fully charge the battery. Now we are looking at how long it's going to last when it delivers that 2000 watts 200 volts load. Now, so we said that we used 4 solar cells, and their arrange is 2 of 2 series in parallel. That's 2 series in parallel with another 2 in series. All right. So our load is 2000 watts and our voltage is 200 volts. So with this formula, we can be able to know the current that is drawn by our load, which is 10 amps. So for 10 amp load current, it will take the battery at full charge 40 hours to constantly deliver the current to the load. Look at how I got the 40 hours. The total capacity is 400 ampere hour. So we are taking 10 amps from this, our total energy source. So when 10 amps is taken from this, it will take it 40 hours to be able to exhaust the energy that's been stored in our battery. I think that has answered our question. If you have any more questions, just leave it on the comment section. I'll be attending to it. I just give you a basics. In my next video, I'll be giving you the design, the arrangement, the construction, how this is being constructed, the solar, the wiring, the cells. I will show you how it's being connected to the inverter, and how the battery is also being connected to the inverter, and how the inverter is eventually connected to the load. Just stay tuned. I'll be taking it step by step. I just want to give you a basic so you know what to expect. You know how you have to calculate the number of batteries, the solar. You don't just go to market and say, give me 5 solar cell, give me 6 solar cell, give me 20 batteries. No. You work with your load and how long you wish for the battery to last, and how long you want it to charge. Some want it to charge under 6 hours, some 4 hours, some 8 hours, some 10 hours. Then they want it to deliver for 24 hours. So all this is what we take into consideration. So you have to just go through my video one more time to be able to understand this. But if you have any question, leave it on the comment section. I will attend to it. And stay tuned to my channel so you'll be getting more of the interesting